In this episode of Finogric Machining, we are going to make a locking nut for the rotating welding positioner. Okay, so well, let's start with that one. Okay, so this is the material. This is a chuck which I have cleaned up quite thoroughly, as well as I could do it without taking it apart. And well, yeah, you know what happens next is that we just put this in. I already made this. This is 90 millimeters in diameter. It goes in there, and I just now put it there somewhat. Like that. This is high. So because this is low, we loosen it a little bit, and this is high. Let's tighten it. Well, it's not too bad. Well, it's really bad, but not too bad. Okay. The only tool that it's here, hiding in plain sight. So just put like that. Then we lock the compound. I don't want it to wander around, like that. And then what we do, we don't lock the compound. We are feeding with compound. I want it to wander around. So let's see, there is our surface. I take it just a little bit away from that, and then I lock the carriage, like that. And then I probably would like to see if there are some really high spots. Actually not, it's quite straight, looks like. And then I'm using that kind of feed, carriage feed, middle speed. There you are, and then the speed, feed direction. Wrong way, correct way. Speed is quite alright. Well, we are having a gear speed. This traditionally changes the feed direction. So now we can switch off the gear altogether, so it doesn't rotate there. Well, now it doesn't. So now let's see if we can touch this. Yes, we can. Okay. Then let's zero my dial here. So I will take half a minute. Oh no. 0.25 first. Let's see how it looks like. silky smooth. Okay, that's well, I think we have a good surface there. Nothing to complain about that. Oh yeah, okay. Okay, next we will peel off the outer outside of this workpiece. What we will be needing finally is 15mm thick piece of this, and there will be a hole inside, etc. But now I need to give some extra room for the parting tool. It will be 3mm. So I have set up this, the width of that, to 18mm. So I have locked the carriage and everything. So I just put the blade against the surface, and then I adjust this hard stop here. Yeah, there you are. Tighten it into place. Note, no Allen wrench. Very nice. So put it there. Okay. And then my safety goggles. Yeah, because we are going to touch and it can throw away already who knows what. So we are here. It stops there, and then our speed is like that. Well, the speed is actually 150 revolutions per minute. I will be feeding in, well, let's see, its speed. It will be 40. Well, it's almost 0.1mm. That's too much actually. I need to adjust this one. I put it down to now it's 0.07. I would like to be even. Well, let's try that one first. Well, 0.1mm sounds bad for that kind of thing, so we will make it slow, really slow. So now it's 0.03 of a millimeter per revolution. Okay, direction. It's all right. And now let's start. There you are. And I'll zero this one. And we will take one, well, half a millimeter. And let's just see how it does. Well, the feed is really slow, but so is the speed. So let's see if we can speed this up a little bit at some point. But I really don't want to destroy that tool. Well, it's really slow. Takes time. Okay, there you go. Well, we are going to need a second pass to clear this out, but so far it looks good. Real good. So, and it doesn't make too much of a mess. Really good. Okay. So the cut was deep enough. Let's see. One more time. Yeah. I think it will clean out with the other pass. So let's let it do this. No, it doesn't clean. So we take it a little bit back and put 0.25 millimeters more. And let's see if this cleans it up. I don't want to make any more passes than I really need to. So this should clean it out. Look at it, it's clean. Okay, let's go. Done. Over and done. Okay. Okay. Okay, now it's a little bit over the center line. That should do the trick, for sure. Oh yeah, there it is. And now the speed is really important here. First of all, the feed. Last time when I did this, I noticed that it likes high speed and low feed. So about 1000 RPM. Let's see how this looks like. Let it be that. Slowest possible feed, hopefully in the correct direction. And now I will touch it with my safety goggles. Here. There you are. is one very important thing which I have forgot to do. You know what it is? I forgot to tighten the tool. Ah, well, oh man, I need to redo the touch. I take it from here in the bottom. Oh man. That sound was not good. Hopefully it didn't break. Well, 1/10 of a millimeter and now 0.25. Let's see now how we do. The diameter is about 33 millimeters at the moment. I'm running this, at the moment 180 revolutions per minute, and the feed is, it is 76 hundredths of a millimeter per revolution. And this is, the cut depth is 1 millimeter. Now it's 1 millimeter, and the surface finish doesn't become good, but this is hogging metal at the moment. Okay, now we are at 47 millimeters. I will now half the feed, half speed, and double the speed. Now it's actually double. Yep. And I will only take half a millimeter cut. There you go. And let's see how it does. Hopefully I don't get very long stringy chips now. That might be the case, but let's see. So, the chips are nice. Really nice actually. And now I would like to measure this one. We should be somewhere around 47.5 millimeters. Somewhere around there, yeah, really. Okay. Well, we are 300ths of a millimeter over, I believe. 300ths of a millimeter over. Hopefully you can see that. So, well, okay. So So I will not take the entire 0.5 millimeter, I will take a little bit less. Like that. And once more again, this diameter is not well, it's okay if it is plus minus 300ths of a millimeter. It's still okay if it is plus minus 500ths of a millimeter. But I would like it to be quite exactly. So there you go, the last pass. Well, wish me luck. Well, let's see now. Nice finish, yes. Feels nice and looks nice as well. Yeah, okay. And now let's see about this. If I can get this correct. So we should be in 48 millimeters quite exactly. Well, I don't know why, but it looks like we have offset it by 500ths. That's funny because it shouldn't happen. But let's see, it could be a measuring mistake. Yeah, it was. This time I'm getting maybe 100ths of a millimeter overshoot. That's entirely okay. Even the 500 would have been okay. But I want to demonstrate how to make a perfect hole. Well, let's say near tolerances. Yeah, it's still like 100ths of a millimeter over. And this is what I get here. Consistently. There you are, maybe. Okay, so 48 millimeters and 48.02 maybe, and oh yeah. So now I'm quite ready here. What I will do, I will actually make a starting groove inside there, and this is why I adjusted the compound a little bit. So I need to go there. Well, actually, I would like to touch first somewhere. Now it's touching. Let's zero our dial here. Like that. Well, oil. Okay. Yeah. So now I would like to go back in there and then, well, just make a groove there. 2.5 millimeters deep, at least. And I will actually use the compound now to make it a little bit wider. Then I'll go a little bit deeper. And then again a little bit wider. It likes to resonate. So what I will do, I will decrease the speed a lot. Not that lot. That's better. And I also should use this speed for making the thread itself. Yeah, this sounds better. Okay, now it's 2 millimeters from diameter, so 1 millimeter deep. It tries to sing to me. And there's the 2.5 millimeters now. We are deep enough, and now just widen it a little bit. Wait until it stops. Okay. Then we go back to 0 here. And then what we will do, now I lock the compound here. There you are. Stop. Retract. Past 0 and go away. Yeah. Okay, we have a starter groove down there now. Well, there you are. There is our starting groove, and now I will, well, I don't chamfer this one at first. I will do this as the last operation. Now I will start making, this will be the scratch pass now. Again. So it's only 0.1 millimeter. Make the scratch. This is a 2 millimeter thing. So I will just check it. Nothing fancy about that. And it is as expected. So now I will first oil it, put some oil into there. There is this hard stop which I'm using here, and then we dial in, 0.25 millimeters. That was 0.25. Now it's 0.5 millimeters. Yep. 0.75 millimeters. was 1 millimeter, and it's already grabbing quite a lot of material. Good. Now I would add a little bit more oil. So 1.25. .5. Well, it's smoking. Oh, nice. Okay. Now I'm starting to take 0.1 millimeter cut, so it's 1.6 millimeters. And actually there is some residue from the previous cut because of the flex of the tools. So nice chips and very nice looking thread down there. Well, I have a little bit of a break now. It's fairly hot and I would like to have a cup of coffee. Okay, coffee break is over. So now, well, I will demonstrate you what I'm doing here. So, first of all, the last cut was from the diameter, it was 1.6 millimeters, like here. You can see 1.6. Next will be 1.7, so I will get this back a little bit, and then I will put it there inside. I'm having here my hard stop. Now I know that it's in the starting point. Then I advance this one to 1.6 and 1/10 more, like that. And then I will start the lathe in reverse direction, and this is important, like that. Now it's turning. And the next step is to engage the half nuts. Hopefully this goes well. Yeah. And there you go. It makes our next cut there. Like that. And we have no hurry here on stopping this. But let's just disengage the nut and retract it. Maybe clean up this a little bit, and then put it there against the hard stop, and the cycle begins 1.8 millimeters this time. So let's see now. So 1.8.
we put you somewhere else, like here maybe. Might be a better view. Yeah. So we need a little bit more oil into there. Now it's 1.9. Let's see now how we can do this. Two point zero. A lot of stuff in here. Let's take some of that away. There is very minimal burr, and that's nice actually. So our goal here is something like 2.3. So 2.1 now. No, not yet. Oil. That's the wrong direction. Two 2.1. Okay. I'm not sure whether it was 2.1 or 2.2, but well, then it becomes an unintentional spring pass, and nothing bad about that. Now 2.2. 2.2. Yep. And then 2.3. 2.3. It was quite... No, it was not completely dry. I can do this without additional oil. Now I'm going to do a few spring passes until it stops cutting, and then I think we are actually ready. I will try it Oh yeah, it looks, well, it looks as it looks. I'm not sure whether it is good or not. Let's see. With this one you can feel it, whether it is good really. Chips are making contact there. And then 2.3 again. There you are. And it's actually making contact somewhere there now already. Oh yeah. There is a lot of flex in this one, so therefore this 2.3 makes quite heavy cut actually, even though it was a spring pass. So one more at least. Spring pass I mean. There you are. Well, this one is no more cutting that heavily, but it's still Let's make one more spring pass. Let's see. Well, this is the first try for this. Oh, and it's really uncomfortable to test this, but you know what, this is okay. It's a little bit loose as it should be, not should be, but it is a little bit loose. Good. Well, I could try to put it in all the way, and it goes easily actually. Not too loose actually. It's goes there like nothing. Yeah, good. And it's not loose. No, that's perfect. Thread. Oh. Yeah, there you are. So now we are taking care of the angle grinder finish here. I was not able to cut it totally through with the parting tool, so I needed to angle grind it off. So now I have dialed it in. There is this very small ledge here, which I was using to dial it in, and it should be quite there. And the speed is at the moment 280 revolutions per minute. Feed is
Well, one B. It's 76 hundredths of a millimeter per revolution. So, and now I'm going to touch it a little bit. Let's see first of all how it runs. Well, yeah. Touching. There you are. Then I zero this one so I know how much I'm taking per turn. Okay. Well, let's take not liberally this time. Let's take. Oh yeah. Let's take this. So it will be 0.25 millimeters at first. There you go. And how about our feed direction? It should be alright, but you never know. Yeah, it is. So now, let's see how it does. Let's see how much we have there, not a lot. I will now touch this surface here, not the inner one, but the outer. So I know how much I need to take off, how much more. There you are. And it is, this should now clean up the whole surface. Well, let's see what happens. I will also slow the speed down. Feet, I mean. Now it's only half the feet. aligned drill in the place, and now it looks like we are a little bit aside. There you are, that's the place. I put a little bit tension in there. I want to start it first. Let's see how it goes. It goes really nicely. And then I just put some cutting oil there. And away we go. Through. There you are. That's the last hole. Okay, now how this is supposed to work is that we have this threaded gear here, which is then used to tighten, preload the bearings. And then we have this lock nut, which threads in like this. And of course you could like tighten it there, and there you would be. But, well, where is the... At this point we had one. So, but what I can do now is to take it a little bit back, then thread in these. So when you tighten the bolt, it will squeeze these together and will lock the threads really tightly. So, okay. And you can get it off by just losing these, and it should come off like that. Yeah. Yes, you need to chamfer these, and well, I'm using my Makita drill here. It's not very... That's one. That's two. That's three. Well, there you are. Okay, I consider this locking nut done. It works really well. After one of the holes was probably 0.25 millimeters too far from the center, so I just filed it a little bit, and now it's all right. And yeah, and it locks really well. You don't need only the tension with your fingers here, and it already locks. Not to talk about when you use your Allen wrench to do that. So it should be, well, if not perfect, very good is probably the... well, I could have made it a little bit more beautiful. Yeah, well, this time I'm a little bit lazy. So, okay, in the next episode of Inno-Greek Machine, we are going to do the contactor, which is contacting this area of the shaft. And this one will be done in a mill, and there will be a radius, this radius, and it will be a little bit complex part to do. So let's see how that goes. The material will be bronze, bearing bronze. And yeah, okay. But that will be in the next episode of Inno-Greek Machining. Well, yeah. Till then, see you!